Oh, hi there. Thanks for showing up for your learning. We're looking at the daily math practice level 1. These practice problems are designed to be easy to create. You can do them anywhere where you have a pen and paper, and you can even start to do these in mental math if you are waiting for the bus or otherwise standing and kicking rocks. So in any case, one of the variables that we want to progress is difficulty with these problems. And so I'm showing you an easier playthrough and then a harder playthrough. We also want to develop our accuracy and our speed. So that's why I'm showing you the timer down here. So we're starting at 2:26. We're going to go through the easier playthrough. Our first skill is to solve for x. So I create this equation randomly, and then it's got a mystery x in it. Let's solve it. So my steps would be to subtract 5 from both sides. I get 3x equals 14, and then I divide both sides by 3, and I get x is equal to 14 thirds or 4 and 2 thirds. But on the SAT, I would code it that way, 14 over 3, or 4.66 would be fine. So that's the easier one. Next, we're going to find the equation of a line from 2 points. With these types of situations, absolutely visualize it every time. So I visualize the xy plane. Here's 3, -1. Here's 7, 5. And I see that we're doing something like this. So here are some things that I expect. I expect to have a positive m value. My slope is going to be positive, and my b value there is going to be less than 0. It's going to be negative. So m is going to be greater than 0, and b will be less. So now let's go ahead and find it. First, I'm going to find m, and I like to do these in my head, but I'm showing you my work right now. So m here is rise over run. So this rise is -6 and runs -4. And that's another way of saying 3 over 2, but positive. Okay, so I know that this equation will look like y is equal to 3 over 2x plus some value b. Oh, I also checked that against my visualization while I'm going. I knew m was positive, so 3 over 2 fits. It's a positive number. All right, now I have to find b. And so I can do that by substituting in one of these points, and so I'll choose that one, 7 over 7, 5. So when y is 5, x is 7. So we'll have 3 over 2 multiplied by 7 plus some value b. And then when we do this, we're going to get 5 is equal to 21 over 2 plus b. Let's subtract 21 over 2 from both sides. And 5 minus 21 over 2 is -11 over 2. So b is equal to -11 over 2, or -5.5. So my equation is y is equal to 3 over 2 x minus 11 over 2. Circle it, that's my answer. Okay, cool, let's keep going. All right, then we want to create some systems of equations that we can solve. All right, so these you can also graph these and work on them graphically, but these I just tend to crunch them algebraically when I see them on the SAT. I don't tend to spend a lot of time graphing them. So here I've created one that's rather easy to solve. I notice that if I multiply this equation by 2, then that will give me 2 times 3x will give me 6x. 2 times -2 will give me -4y. And then 2 times 10 will give me 20 on that side. Now I can add these two equations together and it will eliminate the x's. So 3y minus 4y gives me -y is equal to 11 plus 20, 31. I always do addition of two lines. I would have multiplied by -2 there if I had to make these coefficients here opposite. I want them to be the same absolute value, but the opposite sign, so that I add them together. When I'm adding, I'm making fewer mistakes than when I'm subtracting. So always add is my tip. Y is equal to -31. So now we're going to go ahead and find out what x is. So we can use this equation over here. So I know that 3 multiplied by x minus 2 times -31 will be equal to 10. Interesting. So -2 times -31 is positive 62. So we are going to be subtracting 62 from both sides. And that gives us 3x is equal to -52. And then we divide both sides by 3, and that gives us 71 1/3. So x is equal to 52 over 3. 52 is not divisible by 3, but it does happen to go like 17 times 3 is 51. So this is 17 and 1/3, but it's negative. But I wouldn't write it that way. I would write it negative 52 over 3. Cool. So that's how I would solve that one. And then here's a question type that shows up so often on the SAT. Like they will say 3x plus ky equals 10, or maybe they have hy or some other variable, by, whatever. And they want you to find the value of k that makes there be no solutions. So actually what we want to do in this question is just practice this skill. And we want to create the same ratio between the coefficients here as we have a ratio between the coefficients there. That's going to create a situation where we have two parallel lines, and two parallel lines will never touch. We never get this situation where there's our solution. So that's what we're looking for. So we create a value of k that makes those parallel. So I can see here that this one is half the size of that one. So if I have something here that's half the size of that and the opposite sign, then it will work. So my equation would be 3x minus 3 over 2y equals, and I could say 10. So I have 10 like that. Later on, I'll check that in Desmos, and you'll see how I check my answers and that this is correct. And another thing I should highlight, if you have questions while I'm doing this, you absolutely want to email me. You can say, hey, Grant, you were creating systems of equations with no solutions and went way too fast. I might need a lesson on that. Can you break that down for me? We can spend 10 minutes in a class to go over this. This is a lot of points on the SAT. Okay, that's enough about that. So now we can also use this system of equations that we started with here and create infinite solutions with just changing two of the variables. And so you could choose two variables at random. Let's say we have 3x plus some amount equals some amount there. So I've got a blank there and a blank there. And then down here, I've got negative 6x plus 3y equals 11. Infinite solutions means we have one line that looks like that and another line that looks like that, like they're the same line there. That means that there's infinite number of points along those lines that would all be solutions to this equation. So to create that, I need the ratio here to be the same. Essentially, the two lines have to be algebraically equivalent. So this one would be here the same value, negative 3 over 2y. And then that would want to be, well, this one is half the size of this one, and also the signs are flipped. So this would be negative 5.5 or negative 11 over 2. Okay, so that's done. Now, I note the time, 2:33, so that took me 8 minutes. Practicing this for 10 minutes a day is very good. So I'm happy that I've done this practice. I also was talking, so that slowed me down a bit. And it might have slowed you down a bit too. So then I come in here, and I'm going to go ahead and kick up Desmos. And you want to use Desmos to check your answers. And I'll show you how to check your answers very quickly using Desmos. So I go ahead and take a look at my playthrough, and I say, okay, 3x plus 5 equals 19. 3x plus 5 equals 19. And then I find here that it's 4.667. Okay, well, that's actually 4 2/3. So there, I was correct. See how it shows me where it is? Those are all the solutions of x that do that. Okay, cool, eh? So then I have 7, 5. So I can write points just the same way, 7, comma 5. And another one was 3, comma negative 1. Put that one in there. So that matches the visualization that I had here. And then I go ahead and just graph the line that I found, which was y equals 3 over 2x minus 11 over 2. Bink! When it bullseyes those points, you are very happy. You know that you are correct. Okay, and it's fun. It gives you that feeling of ding. Okay, I got it. I know that it was correct. Next, we have this system of equations here. So let's dump the system of equations into Desmos. 3x minus 2y equals 10. Okay, there's what that line looks like. Oh, that's amazing. It's parallel to the other line that we were working with. And then we had negative 6 x plus 3y equals 11. Okay, there it is there. And we found that they met at negative 31 and negative 52 over 3. So here I'm going to zoom out, move way down here, zoom in on that point, and then find that they intersected at negative 31 and negative 17 and a third. Oh, that's what I found. So I'm very pleased with myself. And you, it's good to feel good. So give yourself a little pat on the back when you're getting these right. And you're doing this every day, so you're feeling really good. And if you're having trouble with them, then you reach out and talk to me. Okay, if I change that k there from negative 2 to a negative 3 over 2, did I do that? Yes, I did in the right place. So I'll just turn this one off, and then we'll notice that these are now parallel lines. See how they will never touch. They will always be separated by the same amount. So they're now parallel. Okay, so now I am correct. That was indeed the system of equations with no solutions. But what if I change this 10 to a negative 5.5? Okay, and then I zoom in. And if I toggle, this is how you check these. You toggle this on and off and notice that they're exactly the same line. And because they're exactly the same line, we are correct. And we've done our questions for today. So that took me, what, about 4 minutes to check my answers? Oh, but Grant, I don't have a computer. I'm doing this on the bus. Well, you get Desmos on your phone. The Desmos app on your phone, I'll just call it up here. I was doing some work on Desmos earlier today, and you can like quickly visualize things that are really hard to graph or to visualize. Just like check your algebra and stuff. And it's super awesome as an app for your SAT prep. So definitely use that. Okay, so that was the easy playthrough. Let's walk through how you structure your practice, and then I'll do the harder playthrough. Okay, so the first thing that we want to do is have a notebook and pen or pencil ready. So I'm doing this on my tablet so that you can see it, but you can do it in a notebook. It's pretty nice. Start with 3 meditative breaths. My body feels pretty darn okay. I feel pretty relaxed. I don't feel any test anxiety. My mind's a little busy about what I'm going to tell you next, but when I stop and observe it, it gets pretty quiet. I feel not anxious. I feel ready to perform. And then I want to visualize my SAT success or recite an affirmation. So I'm actually going to choose to visualize one of my students, it might be you, getting that letter that says 1530. Man, it feels really good for you to have gotten that 1530 on the SAT. I feel awesome right now, and I want you to feel awesome when you're practicing. So that's why I have you do this meditation before you practice every time. Then you create questions. This level is solve for x. Oh, we could actually add or subtract two fractions, but we get a little bit of practice with that with the lines anyway. Find the equation of a line from 2 points, solve systems of equations. Okay, you do that. Time yourself. 5 minutes of practice is good. Do 5 minutes. That's good. 10 minutes is very good, and 15 minutes is excellent. If you spend a little longer, that's excellent. And then practicing once a day is good. Hit that. Hit it once a day, 5 minutes. Hit it twice a day. That's very good. Hit it 3 times a day. That's excellent. And then we're going to check our answers and write down our time and our score. So my time was 8 minutes. And then my score was all correct. So I'm just going to write down 100%. But if I found any mistakes in Desmos, I would make a note of those. Okay, let me move my face. And you'll see that with this harder playthrough, I just added more stuff here for my solve for x question. I have distribution to manage. I have like terms to collect, so it's harder. We'll try that in a second. The line from 2 points, you can use rational numbers or even radicals in there, and that would be beastly. But that you can say for another later week. For now, just make the points further apart, and it's going to tend to be harder. Okay, solving a system of equations. This one, I created one where I knew I would have a very easy time solving it. This one, I know there's like no easy ratios to multiply by, so this one will be a little more challenging. and then creating systems of equations with no solutions. Again, because I'm working out of this one, all I'm going to do is remove one of those variables, and then when I add that in, I can create a situation with no solutions and a situation with infinite solutions from the same thing, and then test it in Desmos. Okay, 240, let's go. Okay, so here I notice that I have 21x minus 14 equals a negative 55x minus 33 plus 8x. So then I am going to be adding 47x to both sides and adding 14 to both sides. That's going to create a situation like this. 68x is equal to negative 33 plus 14. That's going to be negative 19. And 19 and 68 don't happen to share factors, unfortunately. So my answer is just going to be negative 19 over 68. And that's such a janky number, you'll never see that on the SAT. So I'm done. X equals negative 19 over 68. But I get some practice. All right, let's go. Getting the line from 2 points here. So I visualize. I'm first going to visualize this over here. 537 is way up there, and negative 19.5 is way down there. So I'm predicting, that my line, I'm predicting a positive b value for sure, and a positive m value. So I'm going to use that prediction to error check. So my m is rise over run. So this, I'm going to go this direction, so I get positive numbers. Rise is 32 and runs 24. And 32 over 24, those share factor 8. So that's the same thing as 4 over 3. So this one shouldn't be too bad. And now another trick I can use is I know that I'm just going to apply that slope from 5 and go down from 37. So if I subtract here 20 over 3 from 37, then that will do it. 37 minus 20 over 3. 37 written as thirds is the same thing as 111. Yeah, 3 times. Yes, indeed. It's 111 minus 20. So that brings us to 91 over 3. So b is equal to 91 over 3. So my line is y is equal to 4 over 3x plus 91 over 3. That's like very, very close to 30. And so this is definitely positive, and we're rising at 4/3. So I believe that's good. Circle it. We're going to check it later. Okay. Solve this system of equations. Well, to do that, I'm going to multiply this one by 4 and this one by negative 5. Okay, so that I'll get the following equations. I'll get negative 55x plus 20y equals negative 5. And then I'm going to be adding that to 32x minus 20y equals negative 12. So these are going to add together to negative 17. And that's going to eliminate the y's. And then here, negative 55 plus 32 gives us 23. Negative 23, x is equal to negative 17. So x is equal to 17 over 23. One way to now proceed would be to substitute that back into the original equation. Another way is to solve it with a different multiplication. So instead, I can multiply this one by negative 8 and this one by 11. And then I can eliminate the x's and solve for the y. Sometimes I find that this is easier than substituting a janky number back in, so I don't have to work with a janky number as much. So here, this will give me 88x minus 55y equals negative 33. And this one multiplying by negative 8 will give me negative 88x. That will eliminate my x's. Plus 32y. Oh, that's so cool. That's so cool. This is the same numbers I had there for my x's and my y's. That's so interesting. Why? I'll have to figure that out later. Wow. So neat. Think about that more later, of course. Plus 20y equals. Okay, I just not no. Oh no, I'm multiplying by negative 8. No, so this is positive 32. Yeah, see, I was almost about to make a mistake there because I was spending so much time looking around at the beauty of this weird thing, and then I caught my error. So it's when you catch yourself catching an error, that's great news. You're doing great. Okay, so here we go. The x's will eliminate, and then we still get 23y. There, that's so cool, but it's a negative. And that's equal to adding those together, negative 41. Okay, so y is equal to 41 over 23. Okay, so circle that. Those we'll check later in Desmos. 5 minutes now. Let's go. Okay, I want to make this so that it has no solutions. I see the ratio here is these numbers are smaller, so I want bigger numbers up here. So I'm going to go with 55 over 4x. Okay, those are going to be parallel, no solutions. Okay, but if I wanted to now create one with infinite solutions, then let's say I go back to having this one here, 8x minus 5y. 8x minus 5y, let's say that we don't know what that is equal to, and that this is equal to some number of x's minus 4y equals 1. Okay, so let's find these numbers. These numbers down here have to be 4 over 5, the size of the numbers up here. So we're going to have 32 over 5x. So I'm just multiplying this by the same thing to, like, by the scale factor to make these two algebraically equivalent. And then here, I'm actually going to divide by that. So this one must be bigger, so this is 5 over 4. There, done. Took me 7 minutes. So I've done a total of 15 minutes of practice today. That's excellent. So 7 minutes. And let's see my score. So you're going to notice I'm always checking my score. I'm going to go into Desmos. I'm going to move Desmos over here. And I'm going to get myself a fresh Desmos. So I can do that just by refreshing the page, reload. All right, and then we're just going to copy out what we have over here. Let's just zoom out a little bit so I can see. Okay, so this is 7 bracket 3x minus 2 end the bracket is equal to negative 11 times 5x plus 3 end the bracket plus 8x. Okay, and I find that that's equal to negative 0.279. Okay, well, what's the value of negative 19 over 68, you might ask? Well, you type it in, 19 over 68, negative 0.279. And this is negative 0.279. So I would say that we got it right, and that's the correct answer. All right, let's keep going. Okay, that's one correct. Now, line from 2 points. So another way you can put in your points rather than doing that is you can put them in a table, and you can go 5, 37, and then negative 19, 5. And we insert a table in Desmos with this button. You can actually insert a variety of different items. Tables are very useful. So another thing that's useful here is I can click the zoom fit button and see both points. And then I can just visually say, yeah, I thought that this B value was like right around 30 and a bit. So that looks like it's collinear with those 2 points. So it looks pretty good. Okay, and then I just type in the equation of the line that we found, or that I found. You had nothing to do with it, even though you're getting a 1530 on the SAT, because I just visualized it. You still need to do your practice. Okay, this is me doing my practice. Y is equal to 4 over 3x plus 91 over 3. Bink! Okay, it binks the points. We're very happy. If we zoom right in, we'll see those points are just like, can't be binked better than that. Okay, let's keep going. Okay, I just want to move this a bit out of the way. There is no out of the way. I can just make it smaller. All right, systems of equations. So let's go. 8x minus 5y equals negative 3. That's one of my lines. And then 11x minus 4 equals 1. I can't see them. Where are they? Zoom out and we'll find them. 11x minus 4. Okay, that's not it. 11x minus 4y. Okay, that will change it. There we go. And then we found x was 17 over 23 and y was 41 over 23. That's what we found. So we go there, just highlight that point. And then you can come in here and write 17 over 23 to find out what that is as a decimal, and 41 over 23. Find out what that is as a decimal, and then just verify. Yep, it verifies. It works. Yeah, so I got that right. Hooray. Oh, and then don't forget, give yourself a pat on the back when you get these right. I'm very proud of my math abilities. I'm not that proud. This is good level, but you want to go to a higher level than this. We're just getting started. So let's keep going. All right, so now I believe if I change this value here to 55 over 40, sorry, 55 over 4, that I will have parallel lines. Whoop-a-dee-doo, look at those parallel lines. They never intersect. It's too bad they have so much in common. All right, so now let's undo that just with the Control Z button. You can quickly undo things in Desmos, super useful. And then I found that if I change this 11, this is down here now. Okay, this one. If I change that 11 to a 32 over 5, oh, they're parallel again. They're just parallel to the other one. And that this was not minus 3, but it was 5 over 4. We would have the same line. Look at this, people. Scored 100% again. It's because I've had practice. So that's a system of equations with an infinite number of solutions. And I can get there by changing a couple of the coefficients. Okay, so imagine as you get algebra skills that are this quick or quicker, because you won't be talking, you'll be quietly writing your SAT and just crushing questions in lightning speed, just how confident that's going to make you feel when you're on the SAT. Now, you're going to develop that confidence by practicing every day. 5 minutes is good, 10 minutes is very good, 15 minutes is excellent. You're going to practice once a day. That's good. Twice a day is very good. And 3 times a day is excellent. So I'm going to consider this. I actually did this this morning, just a little bit of practice. So I'm now done an excellent amount of practice with a very good frequency. So I feel that my algebra skills will have improved today. Not my deeper understanding of algebra, but just my speed and being able to write these things out. So any questions, absolutely hit me up by email. Practice these skills in Delta Math. There's a Delta Math available there. And check your work in Desmos. It's very useful to check in Desmos and see that you are right so that you're building that confidence. And I think the more, none of all y'all work with Desmos nearly so much as I do. And I don't know many people that are as good at math as me. There's a relationship there. So spend a lot of time in Desmos. You'll get good at math too. Okay, bye for now, everyone. Thank you for showing up for your learning.